Let's begin. So this is IOQM 2022, and I may go a little longer today because last day yeah, so problem number 12. Okay, so I'll just start drawing the picture. We have this triangle and PQR are one second points on the sides, so that B, P, Q, R. Okay, that becomes a trapezium. And okay, I think I roughly understand. Let me start drawing the picture. So we have the 60, 60, 90 triangle, 60, 30, 90 triangle. So that maybe like this a little bit. Okay, you people may have tried the question, and even if you know the solution, then it's better actually. So B is 60. Yeah, so this is fine. This is 30. So B, A, B, C, C. So we have point here P, and this point P, are PQ and BR are parallel. Okay. So wait, how can that happen? PQ and BR. Once again. Yeah, okay. So Q is here somewhere and R is on CP. Okay, that was just unnecessarily written, I think. Yeah, this is simply just PQ R and BP is equal to QR. BP will be equal to QR. Okay. Something like this, right? And this is parallel. Okay. This is R. BP is equal to QR. Okay. Find the maximum possible value of this BP-QR ratio. So we have this ratio ABC by PPQR, and we just want to maximize this. Okay, maximize.
Sir, it
Right.
is 2 times area of ABC, right?
Yes, but that doesn't matter. That's I didn't write it because yeah, that would be same. The answer would be just 2 times that. So yeah. So you can see that there is a kind of a push and pull in the sense that if you try to increase PQ, right, then the area does not necessarily increase because the height decreases, right? So at what point will you get the optimal is the question. So any ideas? It should not be difficult, right? I think. So maybe we can say, okay, let PB equal to X. Okay. If we take PB equal to X, yeah, we can, and it's not a problem to assume that AB equal to 1. Okay. Right, because this is about ratio, right? So we can magnify the shape and so on. And so we can scale it so that AB is equal to 1. So if this is equal to X, then QR is equal to X. So in this case, what is PQ? What is BC?
Sir, isn't BC2?
Right. Absolutely. BC is 2. You can use trigonometry to say that quickly, or if you don't want to use trigonometry, then you can also say it, but we use trigonometry. BC is 2. Okay. So how much is PQ? PQ is 2 times 1 minus x, right?
Yes.
And then then what else do we need to know?
Sir, the height of trapezium BPQ.
Yes. So that also we can find now, right? That is, so you can find and tell me what it should be. So you calculate the height, meanwhile I'll calculate BR. BR I'm getting 2 minus x. You just check it. And height,
Isn't the height x root 3 by 2?
x root 3 by 2, right? You see, knowing a little bit of trigonometry, just with basic trigonometry, we are doing these things faster. Okay. Okay. BR is 2 minus x. Is that checked? X by 2. This is x by 2.
Yes,
This
sir.
is,
We are
oh,
no minus.
all right.
Yes.
So, yeah. So then area is, okay, so the top area of ABC will be 2 times area of ABC will be 1 by root 3. Okay, check it, check it. This is the area of the trapezium. Then I'm removing the constants, and then we have to maximize this. Remember that x is less than 1. X is between 0 and 1. Remember this, right? So the problem is now just an algebra question. X is between 0 and 1. Maximize. Okay, something is not clear, tell me. This is the same as minimize, or rather I should say minimum, because I'm writing equal to, so these numbers of the reverse number. Because I know that the number is always positive, right? So I can just take 1 by x. So what is the minimum of this thing? Something seems. No, I mean, so I'm saying that we try to minimize this, and then 1 by the minimum, that will be the maximum. But is something incorrect here?
Maximum will be almost 1, right? No, sorry, minimum.
Minimum would be almost 1. Why? We are doing something wrong. Can you spot it? Because you see, so the problem becomes to minimize this number, right? This thing.
Sir, it was x by root 3 in the numerator, right? Instead of 1 by root 3.
No. This side length is 1, right?
Sir, if you put the formula won't the area be half into 1 into 2 into sine 60?
Yes. No. Base tan 60 or tan 30, right? So if AB is 1, then AC is oh. I mean, so what will AC be? So
2x by root 3.
no. How will x come? AB is 1, right? No, x is not going to come in the area of ABC.
Sir, AC will be root 3.
Yeah, AC will be root 3, right? And so the area will be so this is incorrect. The area, but it won't. So there is still a problem. The area will be root 3 by 2, right? But
Yes,
x
sir,
will not
sir.
come. Yeah, x will not come there. Yeah. See, the problem is that if you look at this to maximize this thing, you can say that then x, if I take x to be very, very small, then this becomes infinite, right? In the sense that it can go larger and larger. So where is the problem? But that should not be the answer, right? Infinite, or I mean, you know that it cannot be more than root 3 by 2 because it's inside ABC. Or I should say, yeah, but maybe the ratio can be, 1 second. So, no, so, okay. So algebraically speaking, you see the area cannot be infinite. I mean, sorry, not the area. The ratio should not be infinite. Can it be infinite? So that's what we are getting like this. Is it correct? So I'm saying that you could take x to be very, very small, 1 by 100, 1 by 200, 1 by 300. Then this quantity will become very, very small, right? No doubt. And then the inverse of it will become very, very large. So where is the problem? So is the answer infinite?
Sir, but if x is very, very small, then 4 minus 3x will be quite large, right?
No, that cannot be more than 4.
Yes.
Yeah. So that is not a problem. The problem is that x cannot be very, very small, I think. So what happens if I don't know. So what happens if it's here? Otherwise the answer will be infinite if we are like this. Okay, so then it does seem like x can be very, very small. I'm just trying to check myself if x can be made very, very small. So if x is here, the only issue that can come is if this, how should I say? Yeah, this 60 degree, right? This is 60 degree. You have to make a thing of 60 degree here to make this line R so that this makes an angle of 60 degrees. And it has to be inside the triangle. This R has to land inside BC. And it will land, right? There is no problem. Right? So, yeah, because the whole thing is 120 degree. So we can make an isosceles trapezium with very, very small x. And in that case, the area does become very, very small. You can just see that in the picture without any calculations actually, right? Because the side length are still bound by BC, right? So the side length still has a bound. Some of the side lengths which is coming algebraically as 4 minus 3x still has a bound. Even geometrically it has a bound and the height goes to 0. So this will go to 0. And so the ratio goes to infinite. Yeah, I don't think there is anything we are doing wrong.
But I think this was a bonus question.
Okay, that is, so this seems to be infinite to me. Yeah. So is a bonus question supposed to be difficult or easy? Or
And no, sir, bonus question in the sense there was something wrong in the question given.
Yes.
okay, so we have found that the question is something wrong. But you see, we have learned something, right? That the answer is infinite. Or we have basically learned that this PPQR area can go to 0. Okay, but we learned it the hard way, right? One could directly see it from the picture that it does go to 0. Okay, right? Yeah. But obviously one has to reason like that, okay, it is going to 0 because the one parameter is bounded and the other parameter is going to 0. Yeah. Okay, so I did not know this was a wrong, maybe bonus or wrong, whatever question. I guess, yeah, if it's wrong, then it counts as a bonus or something. Okay, so let's then move on to the next question. But then main thing is that you see now with the trigonometry, we could do it little faster. We could do the calculations faster. So let AB be a diameter of circle. let's do this question. So this is your IOQM 2022 problem 11. Yeah, this is already IOQM 2022. So, so we have one circle and we have a diameter. This is this diameter. Okay. Then we are taking a point C, which is different. This is P. So this is like a classical picture, you know, this perpendicular draw and so this D and E, right? Center C, radius CD. So you make another circle. Center C and radius CD. So does this look good, accurate? So now we are interested in these 2 points, P. So perimeter, sorry, PQ. Okay.
So I actually read the proof for this question.
Sorry.
Sir, I read the proof for this question.
Okay. Okay, just then give us a few minutes and then you can tell us some, give some hints. Small. Yeah, the radius is not equal. Yeah, so somehow we have to relate the side lengths. We have this much I can see. Mm, yeah, there could be ways to do it. So Aparna, tell us some hints. Could be several ways, but what should be the correct way?
Sir, actually, we need to apply the Tollmay's theorem in the cyclic quadrilateral CPEQ.
CPEQ. Yes, that is one cyclic quadrilateral. Right. Right. Hmm. Correct. That is the correct way, right? So we will say what Ptolemy's theorem is, but this is basically the perfect setup for Ptolemy's theorem, to be honest. Because even if you forget about that first, yeah, yeah. So if you look at this, right, this cyclic quadrilateral, we can now I'm possibly just working backwards and trying to make sense. Okay, this PC and QC, they are equal, right? And yeah, and you see, once you know PQ, you actually know PC and CQ, right? You can maybe assume the radius to be something and work from there. Yeah, if you know PQ, then there's a connection, and so those two are equal, and also this CE is related. That also can be easily found, and that's one diagonal, and this is the other diagonal. So what is Ptolemy's theorem? Ishana, do you know what the Ptolemy's theorem is?
No, sir.
No? Okay. So the statement of the Ptolemy's theorem would be, so if you have a cyclic quadrilateral, so if you have P, C, Q, and E, cyclic quadrilateral, then there's a very interesting relation between the side line. And it is essentially a different result from power of point. Okay. So it's like you take the product of the opposite sides and pair of opposite sides, and then you sum them, and this is equal to product of the diagonals. It's a very interesting, and it's actually in a way very fundamental theorem. It's not like some trick. Okay, this. Let us try to apply this. Okay, then we'll talk about that later. So how do we apply this? Let's see. So we already know in this that PC and QC are equal. So I'm pulling them out, or maybe I'll just call them X. Oh, this is actually a perfect setup for Ptolemy's theorem, right? Wow. Yeah. You see, this quantity also we like P plus QE. What is C? Can we say something about it?
CA is nothing but 2x.
CE is nothing but to, oh, right. It is, I mean, it is there in front. So, yeah. So the problem is done. Wow. So that was just Ptolemy's theorem. So this P plus Q is 24 minus PQ. Wow. I made this thing direct. So you see this CE, right, is again half is 2 times CD, right? And CD is the same as, so all these three are equal, right? They are the radius. And then we can find. Wow, this is a very nice question. A nice, okay, it's just a trick, but it's Yeah, the CD was also the radius.
So
Because
CD will be equal to DA because it's a perpendicular line, right?
yes, right. So just yeah, right. The CD is the radius, but CD is equal to DE because it is perpendicular to because it's I mean yeah, you understand. It's perpendicular drop from the center to a chord, so that will bisect. Yes, all the ingredient. That's why it's a very put in one place. Come, okay, yeah. Hmm. So Ptolemy's theorem is what we can discuss, but let us maybe finish the question. Then we can, if we get the time, we'll discuss it. Otherwise, we'll discuss it next time. In fact, today morning I was taking a class, and yeah, it problem looked like it could be having Ptolemy's theorem, but then it ended up did not. Okay, that was some ISI question. It was easy. It's actually easier than this. Okay, I would say, but yeah, in some ways not, some ways yes. Okay, let's do the next questions, but I think it's time we relaunch the meeting. Let me just check what other question. Yeah, this question 3 also we have not seen. I have not seen, so we'll discuss that next. Okay. Yeah, so let's join again and then discuss the rest. Ending the meeting.